Hello, everyone. Welcome to Ray's Math class. So today I'm going to bring you the topic about geometry and the measurement. As we know and discussed before, the exam of further math, the exam 2, will separate as compulsory and selection. For the selective topic, you must select 2 from the total 4 topics. From the previous experience, most of the students would select the matrix and networks. However, the matrix is quite easy, of course, but network, it contains a lot of concepts and definitions. So choosing more mathematical and calculable would be sometimes a better choice. Now, let's go through the questions. The first one. Airships are a form of aircraft. An airship has a cabin in which the pilots and passengers travel, and a cargo is carried. This is shown in the simplified diagram below. The floor of the cabin is a rectangle with a length of 9 meters and a width of 2.5 meters. The cockpit occupies an area 1.5 meters by 2.5 meters at the front of cabin. This is shown shaded in the diagram below. The remainder of the floor space is available for passengers and cargo. Now, first, calculate the area available for passengers and cargo in the square meters. So the first one, we need to looking for the area which is not shaded, all right? Like the white area. It is a rectangle. Then if we know the measurement, if we know the dimension, we will find out. For this rectangle, the width is 2.5. And the length would be the total 9 minus the 1.5. So 9 minus 1.5 and then multiply 2.5. Look, you can always finish your calculation with your calculator. Do not have to make the calculation on bare hand. The answer is 18.75 meters square. We are doing the worded problem. So not just to find out the answer, the unit is very important as well. Please watch out the details. And that is where us and other students has the difference, had the final different marks. Second question, now we have extra informations. The cabin is a rectangular prism, 9 meter by 3 meter by 2.5 meter. So now we know the dimension of this rectangular prism, and it is shown below, all right? First, we need to find out the volume of this cabin. Volume is length times width. Now you have to multiply the height as well. So directly just put everything in. And then the answer is 67.5, and watch out the unit, cubic meters, all right, cubic meters. The third one, there are 8 windows in the cabin, 1 at each end and 3 along each side. These 8 windows are identical rectangles. The height of each window is 0.5 meters. The total area of the 8 windows is 14.62 meters square. Calculate the length of each window in meters. You may very excited. Okay, this question is very easy, all right? We know the area, we know the width, all right? Like one side of the window, then we just do the division, right? Area divided by the side length, we would have the answer of the other one. I cannot say you are wrong, however, the area is the total area, okay? So you must, 14.62, you need to divide it by 8 to find out the area of a single window, all right? And then you're gonna divide it by the 0.85. This is how we do it, okay? This is how we do it. So most of the students make a mistake on forget about the total area. And finally, we would have the answer is 2.15 meters. Unit again. A cable connects the airship nose to a large concrete block on level ground. When the 60-meter length of cable is pulled tight, nose of the airship is 55 meters horizontally from concrete block. This is shown in the diagram below. Now we have a diagram of a right-angled triangle. For the 60, we know is hypotenuse. For the 55, we know it's just the one side, all right? And the question is asking for the h representing. So we don't have to do the trigonometry. We just need to apply the Pythagoras theorem, all right? The 60 square is equal to the 55 square plus h square. Use your calculator to solve the answer, and h here is representing a real meaning value. So we should discard the negative value, okay? And also we need to round to the nearest meter, which means nearest whole number, all right? Nearest whole number. H is round to 24 meters, 24 meters. All right, the airship body is modeled on a cylinder with a hemisphere at each end. The cylinder has a length of 60 meters and a diameter of 15 meters. This is shown in the diagram below. Determine the total length in meter of airship body. Now, we just need to find out what is the total length from here through the body and to the end, all right? This is one radius, this is another radius. So the total length would be the 60 plus 2 radius. And what is 2 radius? A diameter, and that is 15. The answer is 75 meters. However, more than 40% students make a mistake because the carelessness, okay? It's very easy, it's worth its mark, but it's easy to get, it's hard and painful to lose. Second one, the outside of the airship body is covered in fabric, except where the entire roof of the cabin is attached to airship frame. This cabin roof attachment means that 22.6 meters square less fabric is required to cover the airship body. Calculate the total area of a fabric required. Round your answer to the nearest square meters. So you obviously can see in the bottom, right? The rooftop of this little cabin is attached into the body of the airship. So that part of the area we should not consider. It would be the total surface area minus the 22.6. So what is the total surface area? You see, we have two hemispheres. If we put them together, it is a total sphere. So that will be the area of the spheres. And then we plus the side area of the cylinder. All right, so that would be the length multiplied with the circumference of the circle, because that becomes to the other side of the whole rectangle. If we just fold it up, the side area, the side shape of the cylinder would be a big, large rectangle. All right, one side is the height and the other side is the circumference. So that would be the pi times d. And let's substitute the value. 4 pi times the radius square, that would be the 77.5 square. And then plus 60 times pi and times 15. Let's use our calculator to find out the answer, please. All right, round to the nearest square meter again, round up to the whole number. 3,512 square meters. Okay, all right. Second question. At Brisbane Airport, an airship waited for survey equipment to arrive on a flight from Frankfurt, Germany. The flight from Frankfurt to Brisbane took 23 hours. That month, the time difference between Frankfurt and Brisbane was 9 hours. At what time and on what weekday did the flight leave Frankfurt if it arrived in Brisbane at 6:30 a.m. on Thursday? So this is a local geoscience time questions, all right? The first thing first, we should know that currently our time zone of Australia, Melbourne City, is on the GMT plus 10, all right? And then the Frankfurt is in Europe. So that means we are a bit faster to approaching the next day. So we actually need to counting back, all right? So my method first, now is Thursday, 6:30 in the morning, all right? And then if we trace back 23 hours, because we took 23 hours on the flight. So on the Brisbane local time, Wednesday, 7:30 a.m. is the time takeoff. All right, that is the time takeoff. And then this time is the Brisbane time. It's the Brisbane local time. We need to counting back 9 hours as the time difference, all right? So let's counting back 9 hours, 6:30, 5:30, 4:30, 3:30, 2:30, 1:30, 12:30, all right? And then 11:30 and 10:30. So that would be the 10:30 p.m., all right? And then you're gonna counting back from Wednesday to the day before, which is Tuesday. So the takeoff time would be the Tuesday, 10:30 p.m. at Frankfurt, Germany. Okay, this question, not enough 30% student make it. It is 1 mark again, however, it is more like a common sense. B part, the equipment was used to survey a site in South Australia. The airship flew from Brisbane to the survey site along a small circle. Assume that the radius of Earth is 6,400 kilometers. Now we need to show that the radius of the small circle was 5,702 kilometers round to the nearest kilometers. Now if we draw our Earth, all right? And this is the longitude. And then on the south side, on the small circle, all right, we have 2 points. One is at here and the other at here. And this is our radius, okay? So obviously, you can see that, all right? This tiny little angle would be the 27 degree, okay? Would be 27 degree. So the radius of the small circle would be the 6,400 multiplied with the cosine 27 as it is the angles adjacent. All right, that is adjacent. And then use your calculator to work it out. Okay, that is 5,702 kilometers. As it is a show that question, you need to provide the steps, not just the right. The answer is 5,702. Yes, that is the answer. However, show that requires, gave you the correct answer, but requires the working step. Second one, calculate the distance that the airship flew from Brisbane to the survey site. Round your answer to the nearest kilometers. Now, if we look from the North Pole to the South Pole, the little circle would be look like this. And from one point to the other, all right, we have the little radius, okay? And then we just need to find out the arc length, all right? The arc length. The arc length, we require the radius, and also we need the angle. We know from the eastern 153 degrees and finished at 141 degrees. So the difference of this angle would be the difference of this longitude, all right? So that will be the 153 minus 141, you would have 12 degrees. So your answer would be the circumference, all right? 2 times pi times the 5,702, and then multiplied the 12 degree out of 360 degree. And the answer is round up to 1,194 kilometers. All right, please watch that one thing that, especially for the previous part, everything we discussed is in the degree. So when you apply the calculations, please consider and ensure that your calculator is in the degree mode, not in the radian, not in the RAD, okay? Not in the RAD. All right, last one. Now, that survey was done at night. 2 spotlights attached to the airship cabin based 8 meters apart were set at the same angle so that their beam formed a single spot when the cabin base was 15 meters above ground level. This is shown in the diagram below. Calculate the angle round to the nearest degree. Now, this is obviously an isosceles triangle, all right? Isosceles triangle. So you need to bisect it, all right? If you bisect it, your angle exactly same, your base cut in 2 equal pieces, all right? Oh, sorry, it should be cut to the end. All right, this angle are exactly same, this side exactly same, and also it is perpendicular, all right? It is perpendicular. Now, we just need to find out that the footnote angle, all right? So we bisected 8 meters, so each side would be 4 meters, all right? And then the height is 15 meters, and we're looking for the theta. In this right angle triangle, consider the angle theta. We know the opposite, we know the adjacent, all right? We're looking for the theta. We should apply tangent. So the tangent is equal to the opposite divided by the adjacent, which is 15 divided by 4. And then use your calculator's inverse triangle, all right? You're gonna do the tangent inverse of the 15 out of 4, and then round it to 75 degrees. And then again, watch that out. If you make your calculator not on the DEG mode, you generate not 75, and that is a wrong answer, not accepted by the question. That is the end of the geometry part. So you can see that the geometry part not only requires the basic calculation skills, but also requires some common sense. You need to be careful, be vigilant, and if you read smart enough, then it is not hard to solve the geometry questions. However, I'm not always recommended you select the geometry. Just go through all 4 topics and choose your best 2 of them. You don't have to do all of them, all right? Just the 2 best. Maybe in the normal days, you are best at networks, but if the network question is too challenged, choosing another topic is also a smart move. Thanks a lot, and thank you very much to attend my math class. If you're interested about our institute, please contact with our administration, follow our public account, YouTube, Little Little Red Book, and other sources. Have a good night.